Hello and welcome back to our recordings. Here we're taking a look at the vulnerability scanning lab that begins on page 56 in the current version of the workbook. And to get myself started, I'm just going to log into these different virtual machines. And as usual, I have not read ahead, so I'm not actually sure what it's going to ask us to do. So we'll kind of explore through it together. If we run into a couple of mistakes as we go, well, that's just fine. Now let's see, so it's mentioning here that for this exercise we're going to be taking a look at a tool called OpenVAS. Now that's just a open source vulnerability scanning tool that's freely available. It can be a little bit tricky to get this installed and running, but I think that this particular system, the auditor system, has everything already set so that we're ready to go. Now it does mention there in step 1 we're going to want to get a couple of services running. In the command lines it's showing that we would run these using sudo. However, as you can see looking at my screen, I'm already logged in as root, so I can leave off the sudo and simply do the service send mail start and the service apache 2 start, as well as the service ssh start. And interestingly, it looked like the Apache server and the mail server were already running, but the secure shell server was not. I also see that the next instruction is to start up OpenVAS, but I seem to remember that the last time we were working together, we had actually started that tool up already, and in fact, we did. Now, if you haven't started that yet, you will want to run the OpenVAS D, and the ampersand on the end is kind of important. You can run it without that, but if you do, it will remain in the foreground. What that means is that it will be really sitting right there in your console, and you'll be unable to enter additional commands. In Unix, adding the ampersand to the end tells it to move that process into the background during execution. And actually we can see that because I'm about to run the OpenVAS client, which asks that we do the same thing. All that means is, notice that it had immediately come back, let me move this down, it had immediately come back with a command prompt, and this right here said that job number 2 was being put in the background with a process ID of 27947. And then we can see some messages coming up, not particularly important, just some configuration problems, very, very typical in a Unix application. And in fact, if you were to take a look in the log file of even a Mac, you'll see that quite often when you open up graphical applications, there's lots of little messages that are going on in the logs. All right, but we've got the OpenVAS client up and running now. Let's see what our first task is. So I'm moving on to page 57. And there on page 57, it's actually going to have us start by, I went a little bit too far. At the bottom of page 56, it says after the client has started, we should click on this right here. This is the connect button. And when we do that, it will ask us to log in. Now, the localhost and 9390 information is already populated. That is where our vulnerability scanner is running, right here on this machine. But root is not the right user ID. The user credentials that we've got, according to the book here on the bottom of page 56, is a login of auditor with a password of password. And let's see, display and remember, don't care. Yep, that's fine for me. Let's see. Yeah, that's just fine for me. So we're using a self-signed certificate in this case. That's okay. We can click all right. Yes, I will accept the certificate, and it will begin to connect. All right. So now while that's working, I had been looking ahead on page 57, where step number 3 is not to run a scan, but to start up a sniffer. And I had mentioned in the course and also in one of the other labs that you would be working a little bit with a sniffer in this particular lab. And the sniffer we'll be using is the one called Wireshark. That's a very, very handy tool, very powerful. And we're asked to also run this in the background. So I'll start that up. Off it goes. And I see that something was trying to get my attention there. Yes, warning, you're running as root. That is okay. The reason that we want to run that as root is that if we want to do promiscuous mode sniffing, in other words, if we want to see all of the packets, we have to run it as root. We can't run it any other way. So, yes, it's just fine, but it's giving us a warning because it is considered not such good practice to run user tools as root. Now let's see here. There's some warning about something being disabled. I don't really care about that. All right, so this sniffer is up and running. Let's see what our next message is here. It says, using Wireshark, once it's started, we're going to have it capture data. So all right, let's see about capturing data. To do that, I'm going to go up here to the Start New Live Capture and Show Capture Options. Let's use the Show Capture Options. Oh, actually, no. Let's use the List Capture Interfaces. I'd actually prefer to work through it this way. Looking at the List Capture Interfaces, we can see all of the Ethernet adapters that are connected to this machine currently, whether they're wireless or wired Ethernet or regardless of what they are. In our case, we're interested in Ethernet 0 and LO, or the loopback interface. And in fact, I can see that in the lab, we are apparently supposed to be starting an interface, or at least the screenshot is showing LO. But let me just show you another quick thing here. Notice that the IP address right now is showing 128.226.1.50. If you click on the IP address, though, it changes. Now, do you recognize what kind of address that is? If you said IPv6, you're 100% right. So, depending on how you want to look at your interface, you can simply click on the address here, and it will show you what addresses are currently configured for that interface, switching between IPv4 and IPv6. In any event, for us, we're interested in the Loopback Adapter. I'm going to go over to the Options menu. Now, the reason that I chose to use the Interfaces menu has nothing to do with Unix and a lot to do with Windows. If you do choose to run this tool on Windows, and it works just fine there, it operates exactly the same way. There is a little bit of a challenge, though. In Windows, it can be very tricky to figure out exactly which interface is which. So approaching it through the Interfaces menu allows you to identify it by the IP address rather than by the big internal Microsoft adapter name. So that's why I prefer to approach it in that way. Now, once we've done that, we're over here in the loopback, and we're being asked to just verify a few things. There on the bottom of 57, we're asked to make sure that it's set to update the list of packets in real time. That's pretty important. That's going to allow us to see the packets as changes are being made. If we don't turn that on, we're not going to see much as it's running. We would have to stop the scan first. Also, currently network name resolution is turned off, and that's probably a good idea because these virtual machines, the auditor, internal, and firewall, they don't actually have a DNS server associated with them. So if I were to leave the name resolution turned on, it would actually end up running the sniffer much, much slower because it would be trying to do impossible name resolutions. Let me start the sniffer up. Now with that done, it creates this main interface that has three sections. The top section here is showing you packets as they go by. You could think about it sort of as a network level view. The next window is showing you the protocol breakdown by layers. So here we can see the physical layer, the frame and the Ethernet. There they are. Above that we can see the network layer, and then above that we can see the TCP layer. And then within that, potentially, if it's able to decode it, we would see the application layer as well. Well, as you click on packets in the top, you'll see that the middle window and bottom windows change. So the top level view here, and when I select a packet, it allows me to zero in on it and get the details, so to pull it apart and see exactly how it's configured. And the first line is showing you the summary data, the most important things people usually look at, but you can see that there's actually quite a bit more in here. We can drill in and see exactly how the flags are configured. We could look at the window size, see the checksum, all kinds of things that we can dig right into here to see how the packet is actually configured. Now as we're looking at these values, if we were to click on one of them, let's say the checksum, you'll see that down here it actually highlights where that's located within the packet. So the bottom window is showing you the raw packet payload, what was actually in the packet. All right, we'll come back to these windows in a couple of minutes. Let's get started in doing the test we'd like to do. Now in the meantime, you may notice some packets have gone by. Like here, we can see there's some DNS queries going by. In this case, let's see. Let's open this one up. I can see a DNS query It's a standard query, it says, and then the queries are in here. It's looking for changelogs.ubuntu.com. So this is just an internal query that's being generated by the Unix system, apparently trying to do some lookups for maybe some updates or something like that. It's not unusual to see lots of activity in and out of your machine all the time. Okay, so with the sniffer up and running then, we're now going to switch over and change to the OpenVAS client. Here we are. It has finished loading at this point, so I can click OK. Wonderful. And we are now ready to get started. Now to start our scan, we want to go to the File menu and use the Scan Assistant. Of course, you can create the scan manually if you'd like to, but for our class, we're going to run through it using the Scan Assistant because it's sort of a wizard to let it happen. So I'll call this My First Scan, and we'll just click Forward. And as we move forward, it's going to allow us to configure and name all kinds of things. We'll call this, let's see, what scope would we like to call it? Let's call it Local Scope. Of course, I don't need to have the word scope there. Oh, I do need to have my fingers in the right place, though. There we go. I can call this anything I want and create comments and anything else I'd like to. And then we'll click Forward again. Now it wants to know which hosts would you like to scan. Now for us, we would like to scan the local host machine. If we wanted to, as you can see here, we can define network addresses and all kinds of other ranges, but localhost is what's going to work for us, because I don't really have anything else to scan right now, and we're just illustrating how the scan works. So with that selected, I'll click Forward. It says I'm now ready to go, so I will click Execute. Now when I click Execute, it's going to connect to the OpenVAS server again, and ask me to enter my password. Now I know this feels familiar, it feels like we already did this. It's actually verifying that I have the authorization to run the scan, making sure that I can log in. So I'll leave all of the other defaults correct and just click OK. Wonderful. Looks like the scan is off and running. Okay, I clipped a little out of the video just so we didn't have to wait for it to load the plugins, but I can see now it's actually begun port scanning the machine, though it has not yet begun the checks. While that's going on, I'm going to switch over to Wireshark. And if I do, I can see there's all kinds of data going back and forth. In fact, let's just scroll back here and pick one of these packets, and I'm going to right-click on it and tell it to follow the TCP stream. And when I do that, it's going to extract that conversation out so I can see exactly what happened there. And what I'm seeing is that in red, this is the data that was sent from the client to the server. So it tried to see if this application was installed on the web service and tried to send it this payload. Apparently some kind of exploit. And I can see here the response from the server to the client. In this case, saying the page was not found. Now, of course, we'll talk a lot more about web-style things in the Day 3 material, but by right-clicking and following the stream, I can now reassemble everything that occurred and analyze exactly what test was run. Now, why would I care about that? Let's just imagine that our vulnerability assessment report came back and said that this machine had a vulnerability related to this yabb.pl script. The administrator says, well, I don't know anything about that. I don't even think I have that script. What we can do is come and look and see exactly what test was run and exactly how the host responded. One of the things that you'll see in the web application material is that occasionally our tools create false positives. Now that really shouldn't be any surprise to you, but you'll actually be asked to find one of them in the lab that we have for the web application material. In this particular case, there's not going to be a finding. It's saying that it couldn't find it. But interestingly, we do get a false positive in the web application day because of this very message. It asks a question, sending material in, and then looks to see if that material comes back. And in the lab that we do in the web application day, it'll actually say, not found, and then tell us what it didn't find. And the scanner mistakenly interprets that as being a real find, but is actually a false positive. So being able to look inside, using a sniffer perhaps, can be quite a valuable activity. In any event, let me go back. I can see that we're at 98% on our checks. While that's going, let's just do a little bit more here, observing what's happening inside of Wireshark. In Wireshark here, I'm looking on page 61 in the workbook, and I'm just comparing it to what we have in the slide up in the screen right now. It's not exactly the same, but that's okay. What had happened is I selected a packet and told it to go get me the payload, and you can see that it then created this filter here, tcp.stream equal to 547. Let me clear that. That apparently was the 547th conversation that had occurred. But I can do all kinds of other queries. If I know some of the options, let's say tcp.dstport equal to 443 and press enter, it will now apply that and only show me questions that were sent to port 443. In this case, there were none. Can you guess why? Well, the easy answer is this machine that we're scanning is not running on port 443. There's no service there. Let's switch it over to 25 though, because we know we turned on the sendmail server, so we should see something, and in fact we do. Now, I happen to know tcp.dstport, but what if you don't know what to type? Let me clear that out and click on the expression button. The expression button opens up, it's not exactly a wizard, but sort of a point-and-click interface that can be used to build a query. So let's just roll down through here. You can see that it lists all of the different known networking protocols that we have today, and there is an enormous number of them. Let me just come down and pick something that we might actually have. Let's see here. So I'm looking for UDP, because there actually may be some of that. User Datagram Protocol, so I can click that open, and then it shows me all of the things that can be checked for or searched for using UDP. Well, let me say UDP is present. I'll just do that for now. And when I do it, it adds UDP. I'll apply that. Okay, now I want something more specific. So I'm going to go back into my expression. Sorry, this is a little on the slow side. And again, let's come down to UDP. Here we are. And let's say UDP port or length. How about we say length is greater than, I'm going to say greater than 8. And I've just picked that arbitrarily. Now you'll see that this has turned red. Red means it is not a valid signature, a filter. And the reason we can see here is that it's actually merged the two together. But see, what I'm trying to show you is that we can actually build these progressively. And using that expression button, just come back in and add the word and. Now the one I'm searching for here is a little bit meaningless because I said UDP and UDP.length greater than 8. I could have done exactly the same thing by just looking for UDP.length equal to 8, because if it's not UDP, it would not show up. But the bigger point is that I can very, very easily and even interactively create these filters to search for things. Now what would determine what to search for? Let's come back to the OpenVAS client. At this point, I think, let's see where I am. Oh, maybe not. It looks like the scan, oh no, it looks like the scan is just about done. We're at 100% here, but it has not yet generated the report. Oh, there it goes. Report is done. So now I can come into the report, begin drilling down, and if I found something really interesting, let's see here. So here's a security warning. It found something with the doc directory being browsable. So what I could now do is go and search to see if I can find that query. Now how could I do that? Let me show you. I'll come back into Wireshark. I'm going to clear the expression, and I'm going to use the edit menu. I'm going to tell it to find the packet, and look what I can search by. I can search by display, hex values, or strings. Let's search by strings. I want to search for, I think it was, let me just look quickly here. What was that? It's /doc. So I want to search for /doc, and I want to find that in the packet bytes. Find. And there it is. So now I can right-click and follow the stream. And now here's what actually happened. In this request, it first asked for robots. That failed. It said not found. Then it asked for CVS entries. That failed. Then, let's see what happened next. Non-existent. That failed. Further down, there's Cobalt. Let me make this a little faster. I'll use find/doc. All right, there's the request for doc. And look, there's a difference. It went from a 404 to a 200. So did it really work? Yes. In fact, we get back this HTML page. We can even copy this out. It's a pretty long page there. Sorry about that. All right, I think I'm going to copy that as enough. It's not going to be perfect, but I'll copy that. Let me open up an editor. Let's see here. We've got LibreOffice. What else do we have here? You know, I'll go out to my terminal, I think. I'm going to cat that into finding.html, and I'm going to paste it in. Whoops. Paste. Wonderful. With that done, I will close that up, and let's now open that inside of a web browser and see if we see any content. There it is. So we actually managed to take the content from the packet, put it in a file, and now here we are looking at it and proving that that's what was actually found. That's why a sniffer can be so useful when doing vulnerability scanning. Personally, I find it useful to have one running anytime I'm doing a vulnerability scan. That way, if there's ever any question, we know exactly what our scanner did and can prove to our client or to our company whether or not our activity actually launched an attack that caused harm, allowing us to distinguish our activity from what might be happening normally without any intervention from us. Well, that's the end of the Day 3 labs. We're going to stop here for now, and our next section is going to deal with the Day 3 labs, picking up with our web application auditing.